Hello students, welcome to the next lecture on the June 2023 mathematics paper. Today we will discuss about the real analysis question asked in this here. Myself Dr. Harish Garg, you can simply follow my YouTube channel Dr. Harish Garg and you can simply scan and join my WhatsApp group for the various discussion part. What you will be found on my YouTube channel, there is a playlist of the CSIR UGC net where I have already discussed the papers related to the June 2023 linear algebra, memory based questions and the last 12-year questions related to the real analysis, linear algebra, complex analysis, Markov chain, differential equations, partial differential equation, calculus of variation, integral and many more. All you can see in my this playlist. So let's start with this video. So before start with this, let me tell you I have received the various solutions related to this question. In my last video I have tell you the simple shortcut text for you for this kind of the problems. Whenever k is less than 0, then it has a unique solution, and if k greater than 0, it has infinite many solution. So according to this, you can see this is my positive, so it has my infinite many solution, and this has a unique solution. But the solution, the student has sent me some another kind of the solution in my WhatsApp group here, and we will see whether their solution is correct or wrong. So I can solve this question again in this video, but at the end of this part. So firstly, let me try to solve this real analysis question in this video. I will solve this question at the end of this video. Last question will be my here. So let's start with this question. So remember that whenever there is a question of -1 raised to power n and they are talking about the limit supremum infimum, I mention you always you can break this sequence. This is as n is even and n is my odd always. So look at the first case, when n is my even and when n is my odd. So this is my -1 raised to power n. So it will be my n pi plus 2e divided by 2n. And when is my odd, then it is n pi minus 2e by. And then take the limit as n approaches infinity. So what will happen if you break them? It will be pi by 2 plus 0. And for the below side is a pi by 2 minus 0. That is a pi by 2. So the first option becomes my exponential cos pi by 2. What is the cos pi by 2 is a 0. So e raised to power 0 is 1, which is not less than of the 1. It is a equality 1, but he said strictly less than 1. So this option is cancelled out. Look at the second option, e raised to power sine. Again you can see it's a -1 power n. I can break them again. This is the same problem. The limit will be my pi by 2. So e raised to power pi by 2 is 1. Is it less than of the pi? So pi is my 3.14. This is 2.17. It is strictly less than. That's the satisfied is the right answer. Again, this is the even and odd. I can break them. It's a n pi square over 7n is a separate. It's a plus e square over 7n when n is my even. And when n is my odd, so it will be n pi square over 7n minus e square over 7n. So as n approaches infinity, this part goes to the 0, this goes to the 0. So it will be cancelled out. It will be my pi square over 7. Now you can substitute here. The third part will be e log pi square by 7, which is my finite number. Moreover, e log of is nothing but my pi by 7, which is a finite, but he said does not exist. It's a cancel out. Look at the fourth option. He said e raised to power 10, limit is my pi square by 7, which is always the finite. So once it's a finite, it means limit exists. But in the third and fourth option, he said limit does not exist. It's a cancel out. The right answer is my B, because it's a question of the part B. So only the one correct option is B, right answer. Look at the another one. What is given to you? F is my here. F of y, I can return this function in this nature over y minus x is greater than of the, what is that? This is the gradient. This is my gradient. Okay, so you can write like of this. Now f is convex and concave. So what will happen if f is my concave? What is the meaning of that? It means the gradient will be less than 0. And if f is my convex, what is the meaning of that? Gradient is my greater than 0. Fine. But you can see about that, if because it's a greater than sign, It is my greater than sign, so definitely this must be my greater than equal to 0, otherwise the inequality will not hold. So f is a concave, is a cancel out, this is my convex function. Moreover, this is the definition of the convex function. If you remember that, what is the convex function is alpha x 1 minus alpha of x is always be less than of this nature. This is my convex function, or you can see here the slope and this is always be less than. So f is my convex function. Then the third and fourth, f is a constant. That's a wrong option, because if you simply take f of x is my x square, which is my convex function, fine, but this is not a constant, so this option is cancelled. Look at the another one. F is a bounded, then it is a constant. That's a correct statement. Remember, if f is convex plus bounded, then it's a constant. How? You can see, assume that f is not constant. What is the meaning of that? It means either derivative is greater than 0 or derivative less than 0. So firstly, assume derivative greater than 0. So if this is my greater than 0, what will happen of this? So fy minus fx is my greater than of f dash of y minus x, and I can take y minus x on this right hand side plus of fx. Then how you can take the limit? Now you can simply say as y approaches infinity, this is my greater than 0, this is my for I can simply take x is my c, then this is my arbitrary fixed value, this is goes to my infinity. So what is the meaning of that? Fy goes to infinity. What is the meaning of that? F is unbounded, but f is bounded, so it means this assumption is contradiction. So it means f is my constant is the right answer of this problem. You can see here. Moreover, if you prove that f is my convex plus f is my not constant, this implies f is my not bounded as well. You can see here, this is a convex function which is not a constant, but it is also not a bounded. So the right answer is my B and C. That's a simple straightforward statement of the convex function or convex function. Okay, consider the function f of x is there, which of the following is true? There exists a continuous function. There exists a continuous function such that f is 0, f is 0. So given that this is 0, can you find the value of the y from here? Y is nothing but my x of 2 by 3. So if you look about that, y is nothing but my gx. So therefore g of x is my here. Now what is the I? I is the any interval, whether it's a close, open, semi-close, nothing is given to you, but it is given that 0 must be the part of this. Now look at this function. First option, there exists. It means we need at least one function. That it is not asking for all of the function. It is there exists. Is this a continuous function? Yes. So there exists a continuous function such that this is 2. This is a continuous function. It is 2. Is the right answer of the problem. Look at the second option. There exists exactly one continuous function. You can see that this only one exactly one function is there. This option is also the correct option. There is exactly one differentiable function. So find the derivative of this. It is 2 over 3 x raised to power minus 1 over 3. Clearly say that this is not differentiable at x is equal to 0, or you can see it is not exist at x is equal to 0. It means it is not differentiable. So exactly 1, it is not a differentiable function, so it is not here. If it is not differentiable, then exactly 1 not differentiable, how it can be exactly 2? This is also not right answer. So right answer is only my A and B are my correct option of this problem. Look at this another one. Consider a sequence AN. 2 sequences are given to you. They are basically talking about that whether this is my convergent or not. What is the definition of the convergent is? You have to check whether limit this is my finite. If you prove that this is finite, then it's a convergent. Look at the AN. Can I write this AN in terms of this 1 over n plus say k? So I can take the limit as k1 to n. Now I can take the limit of this. Limit n approaches infinity, AN So now I think you can remember that what I told you in my previous PY question trick. Whenever there is a question of the limit and question of the summation, your target is to make 1 by n as a common. So can you make as a limit 1 by n as a common? You can take 1 by n is here, the rest of the part will be 1 plus k by n. Fine. Now you can solve this integration. You can simply take k by n as my x. So 1 by n dk is my dx. So it will be 1 by n is my dx over 1 plus x. What is the limit? When you take k is my 1, so 1 over n, as n approaches infinity, 0. When k is n, it's 1, as n approaches infinity is 1. So what is that? This is log of 1 plus 0 to 1. So what is this? This is my log of 2, log 1 is 0, which is my finite. It means sequence an is convergent. Fine. So look at this last option is cancel. Now it is convergent and this is the limit of the convergence, so log 4 is also cancel out. Now it has same rate of convergence, it does not have the same rate of convergence. So firstly you have to check whether Bn is convergent or not. Now you can check about this Bn. What is a Bn? 1 by n is a 0, which is my finite. So it means Bn is also convergent. Fine. Now how you can find the rate of the convergent? So that's a very simple. What is the tips, or you can remember? If I say an is my sequence, it converges to the L, it has the rate of convergence. If you define the sequence, say b of n, then the rate of the convergence is my order of b of n, or you can say another constant, say k. Fine. So firstly find the rate of convergence of Bn. So what is that? Bn, what is the limit of the convergence? Is 0. So what is that? Bn is my 1 by n. What is that? It is always be less than of the 1. So I can consider Bn is a constant sequence. So it means the rate of convergence of Bn is my 1. Now if I prove that the sequence an is also the rate of convergence 1, then it is the right answer. Otherwise the third is the correct answer. Now look at that. N plus 1, n plus 2 up to 2n. Limit convergence goes to the log of 2. Definitely it will be less than of this here, n plus 2 plus 1 over 2n, because of this negative it is less than of this. Now 1 over n plus 1, it is always be less than of the 1 by n, it is also less than n, and it is also less than n. Now you can see that it is n over n is my 1. So this sequence is less than of the 1 again, which is same. So the rate of convergence of a n sequence is again a 1. So we can see both have the same rate of the convergence is the right answer. This option is wrong answer. Only A is my correct option. Look at the another one. Which of the following is my inner product space? Very simple. We all know x comma y is always be greater than 0, and if it is a 0, if and only if x is equal to 0. Now here this is the Rn. What is the condition on the n? It is not given, so you can simply take n is my 2. Fine. So what is that? If I simply take x is my x1, x2, y is my y1, y2. So if I take n is my 2, so I and j varies from 1 and 2. It will be x1, y2, sorry, x1 when j is equal to 1. What is the meaning of that? When I is equal to 1, j1, j2, x1, y1, x1, y2, x2, y1, x2, y2. Look at this second part. I and j, this is independent of the j. So I can return this summation as xij separate, yj separate. So it's a double of x1 square, x2 square, double of y1 square, y2 square. This is only for the j. When j is equal to 1, so it is x1, y1. When j is equal to 2, it's a 8, x2 y2. Look at that. When j is equal to 2, it is xj. N is my 2. 2 plus 1, 3. 3 minus j. So j is 1 to 2. Fine. So it will be x1 y2 plus x2 y1. Now that's very simple. Look at this option. Clearly say that this is not greater than 0. If I simply take the pair as x1 is my minus of 10, x2 is my say 1, x1 will be say 1, x2 will be my 1. So what will happen? This part will be x1 y1. x1 y1 is my minus of 10 plus x2 y2 is my 8. It is my minus 2, which is not greater than 0. This option is cancelled. Fine. Now rest of the options you may cancel out it, but I will tell you the simple shortcut tricks for you, because these are the quadratic form. If whenever there is a quadratic form, if you write in terms of this matrix A, B, C, D, then if A is greater than 0, D is my greater, that's a diagonal entries, and the determinant is my greater than 0, then it could be inner product space. Not necessary, but it could be. Okay, so look at that. If I define the matrix corresponding to the last pair, what is that? This is x1 x2 y1 y2. x1 y2, x1 y2 coefficient is 1, x2 y2 is here, rest are my 0. Clearly say that the first case is not greater than. If this condition not satisfied, then definitely not inner product space. If not satisfied, clearly say that diagonals are not strictly greater than 0. This option is cancelled out. Converse need not true. Look at this first option. So if I write this first matrix here, oh sorry, this is A, B, C and D. So if I write this matrix for here, what is that? x1 y1, x1 x2 y1 y2, 1 1 1 1. So clearly say that all the values are satisfied, but the determinant is 0 is greater than 0, not satisfied. This property not satisfied. This option is also cancelled out. Now the three options cancel. Only the right option is my left option is B is my right answer of this problem. Okay, look at this another one. Which of the following is my convergent? If f is my continuous function, which of the following is my here? There are so many methods are there. You can see how you can solve that. If I simply take by the fundamental theorem of the antiderivative or antiderivative rule, if I simply say x is my infinity, f of x, sorry, it's from 1. It is from my 1. So it is my f of 1. So if I consider this is my existence, so it means the left hand side is my existence, say alpha. So it means this value is my alpha. So what is the meaning of that? Limit x approaches infinity, f of x is f of 1 plus alpha. So this will be 0. This will be 0 only when f of 1 is minus of alpha, which is not always true. Which is not always true. So this option is cancelled out. F of n is a convergent, but from here we can never say it's a convergent or divergent. So look at that. How you can think about that? F is a function from 1 to infinity, which is a continuous function. Which is a continuous. You can think about any continuous function. Remember, you can never think about here, because the limit from 1 to infinity is not satisfied. You may think about this function, which is a continuous. Fine. You can see the integration is also finite. It's a 0, it's a 1, 0 minus plus e raised to power minus 1, which is finite. But this property also satisfied here. But this is not always true. Fine. So what you can do, I can think about a function which is a continuous as a 0 function. After some time I can consider one heap, another as a 0 function, some heap, and so on. So if I consider a function like some function as a heap, say n or n plus 1 by n, otherwise 0. Otherwise 0. Fine. Now firstly we can check whether this is my finite or not. So this is my integration is n square by 2 over the limit n plus here. So what is that? This is n plus 1 by square minus n square over 2. So what is that? This will be my n square will be cancelled out, so it will be my 1 over n square plus 2 over 2. So clearly say that this is my bounded, so it will give you a finite limit as n approaches infinity. Fine. So this both the conditions satisfied, but you can see this condition again not satisfied. What is that? When you take n approaches infinity, this will goes to the 1 but not as a 0. So this option is cancelled. Summation of this series is convergent, but you can see what is the series of this? Series of is my n, but this is my divergent series by the p test, because you can see here by the p test this is my divergent, so this option is also cancelled out. So look at the third option. F is my decreasing sequence and this does not exist, then the series is divergent. I think that's a correct statement. Why? This is the standard statement of the Cauchy integral test. What is the Cauchy integral test is? If f is my decreasing sequence, f is my decreasing sequence, integration is my convergent, then fn is convergent. If this is my divergent, then this is also divergent. This is a straightforward by the Cauchy integral test is my right answer. As I don't know what is the fourth option, if I simply say fourth option is none of this, then this is a wrong option. Okay, which of the following sequence is a uniform convergent? How you can check about the uniform convergent? So you need to firstly check whether it's a piecewise convergent or not. Remember, if it is not a piecewise continuous, it can never be the uniform convergent. What is the piecewise continuous is? You can take this limit. If you prove this is existence, then it is a piecewise continuous function. So look at that. If you take limit as n approaches infinity, x belongs to the 0, 1, it goes to the 0. This goes to the 0. This goes to the 0. This goes to the 0, because this goes to 0, 0, 0. So all the functions of this goes to the 0. It means it is a piecewise continuous. But every piecewise continuous is not a uniform convergent. But every uniform convergent is a piecewise continuous. Now, how you can check about the uniform convergent? You have to check about the Mn test. What is the Mn test is? If you find Fn minus f, if it goes to the 0 as n approaches infinity, then it is a uniform convergent. Or you can also see the equivalent meaning of that. If you start from the modulus value, if you prove that it is less than of the m as n approaches infinity, then it is a uniform convergent. Fine. Now look at the first option. Fn is here. You can take any of the sequence from this side. I can simply take 1 is a upper interval of 1, so I can take 1 minus 1 over n. Then what is my fnx? This is fine. Now what is the limit as n approaches infinity? What is that? I can take about this. So it is my e raised to power minus 1, which is not goes to the 0 as n approaches infinity, because what is the f? F is my 0. F is my 0 so this not goes to the 0. It means this is not uniform convergent. Same for here. If I consider the same example, the numerator part will goes to the e raised to power minus 1. This will goes to the e raised to power minus 1, which is not goes to the 0. So this option is not correct option. Look at this option. This will goes to the e raised to power, but because of this minus 1, you can see e raised to power minus 1, 1 plus n e raised to power minus 1, which goes to the 0, because n is my infinity. So it means it is a uniform convergent, but he said not. This option is also cancelled. Sorry, this option is we discuss about here, this option. So only left option is my here is the right answer. But how you can check that? The upper limit is e raised to power minus 1, denominator is e log of n plus 1. So clearly says that it goes to the 0 as n approaches infinity. So this is my conversion. Moreover, you can think also like of this, because we all know 1 is my greater than 0. If I add x raised to power n, x raised to power n on both sides, so if I take the reciprocal, What is that? Xn over this is less than of Xn over here. So which is 1 over n, which goes to the 0 as n approaches infinity. So it means this is a uniform convergent, but he said not. So that's why this option is cancelled. Only correct option is my B is the right answer. Very simple question about here. Okay, look at that. Which of the following is the convergent or divergent? Whenever there is a -1 of this, you have to apply the Leibniz test. What is the Leibniz test is? If you take about here, if you prove that an is my decreasing, an goes to the 0, then this is my convergent. So look at that. If I start from here, if I rationalize them, it will be my this case. Fine. Now clearly says this value is my decreasing because the derivative is being negative. It goes to the 0, so it means this is my convergent. So it means this option is cancelled. This is the right answer. Check about the absolute and the conditional. We can take about the modulus. So what is the modulus of this? What is the modulus of this? It is root of minus of this. If I rationalize them, it will be n plus 1 plus of this. Now if I consider bn is my 1 by root n, then clearly says the limit an over bn is my 1 over 2, which is my finite, but this is my divergent series by which test? P test. It means this is not absolute convergent. So this option is cancelled out. So once this is not absolute convergent, but this is a convergent, it means this is my conditional convergent. So it means B and C are my correct options. If it is from the part B question, then you can see which of the following is the more stronger condition. You can see that conditional convergent is the more stronger condition in this case because it is not absolute convergent but conditional convergent. So this is the right answer for the option B for the part B. If it is the part C, then both are the correct options. Okay, which of the following condition implies the sequence is a convergent? Very simple again. It's a very elementary question. Look at the last option firstly. Think about any sequence which satisfies this property. Very simple. Here, so what is that? If I simply take n plus 1 minus of this, if I rationalize them, it will be here. Fine. So as n approaches infinity, it goes to the 0 and it's satisfied. But you can see this is my divergent sequence. So he said if this condition is satisfied, it's a convergent, it's a cancel option. Look at this another options. Look at the second option firstly. If I said this x of 2n is my convergent, so as I already told you, what is the meaning of the convergent sequence? Convergent sequence means whenever you take here, this is my finite and unique. Fine. So he said it's a convergent. So if I call as a L1. Second is x of 2n plus 1, L2. Limit x up 3n, it's a L3. Now you can read the statement very carefully. They are not talking about whether here or it may be of this. It may be. Okay, because nothing is given to you. But if you take about this sequence, this sequence consists of both the even and odd order both. If L1 is not equal to L2, because nothing is given to you, they are said it's a convergent. Say 1, they convergent to the 2, they convergent to the 0. But what is that? It converges to either 1 or 2. The limit is not unique. It means this option is cancelled. Look at the first option. What is the first option said? Limit the subsequence converges to the same limit. What is the meaning of that? L1, L2 and L3 are same. So once they are same, it means they are unique. So whatever the sequence you have taken, it's a finite and they are the unique is the right answer. Now look at the last option, whether the subsequence, whether this k varies from greater than 2. So it's a 2k, 3n, 4n and so on. It is given that they are convergent. okay, then prove that xn is also be a convergent. So firstly you have to think about what kind of the sequences are here. It consists of x2, x4, x6 and so on. It consists of the 3, x6, x9 and so on. It consists of the 4, x4 and so on. It means it consists of all, start from the 2, 3, 4, 5, 6 and so on. So that's very simple. If I simply construct a sequence, what is that? This is just like say natural number when n is strictly greater than 1. So what is that? If I consider n is my prime and n is my composite, non-prime, fine. So what is that? If I consider this as 0, this as my 1, what will happen? Out of this, if I define the sequence of the prime number like 3, 5, 7, 11 and so on, these are my sequences, these are my individual sequences. If it is my 0, 0, 0 sequence, every constant sequence is my convergent, it's satisfied. And what about the others? A4, A6, A8, A9 and so on, these are my 1, 1, 1 and so on. So what is that? It is again a constant sequence which is my convergent. But you can see what is the limit of the 9, or you can say what is my limit of the 2n plus 1 as n approaches infinity. So if I simply take n is my 1, it will be my 3. A3 is a prime number, so the limit will be goes to the 0. But if I take n is my 4, let's say 8 plus 9, so x9, it goes to the my 1. So what is the meaning of that? Limit, is it unique? Not unique. So what is the meaning of that? If limit of the x of 2n plus 1 is not unique, like of this case, if it is not unique, what is the meaning of that? It means this is not convergent. So as I consider the sequence which are the convergent, because the 0 sequence convergent is also the convergent, but the sequence xn is not convergent, so this option is also cancel out. So the right answer is only my A is the correct answer. Okay, find the number of the real roots. Read the statement very carefully. They are not talking about the at least, they are talking about all the roots. So firstly, it is my odd degree polynomial, and we all know the odd degree polynomial has at least one real root. Fine. So the first option is cancelled. So it means either it has a 1 root, either it has a 2 root, because it's of the cubic equation, maximum has the 3 root. So what is the meaning of that? So look at that. If I draw it graphically, this is the first method. You can think about the graphically. What is the value at x is equal to 0? It's a negative. So when it has a 1 root, one real, this is my real line, x-axis, it has only one real root. It will be like of this, only the one real root. Look at the second, when it has the 2 real root, so it will be like of this. It has the 2 real root. Look at the third case, when it has the 3 real roots, like first real root, second real root, third real root. Fine. It has a 1 real root, 2 real root, 3 real root. Now if you look about this graph, what is that? You can see it has changed their shape. Here the graph is increasing. It is increasing, then decreasing, increasing, decreasing, increasing. How you check about the increasing and decreasing function? That's a derivative. So if I simply take what is the derivative of this function, 3x square plus 3, which is always be greater than or equal to 0. It can never be 0, it is strictly greater than 0. Fine. So what is the meaning of that? F dash is my greater than 0. What is the meaning of that? F is my increasing function. Fine. So you can see that which of the following is not an increasing. You can see this is my decreasing. In this interval is a decreasing. This option is cancelled. This is decreasing. This option is cancelled out. It is always increasing. So that is, it means it has only the one real root is the right answer of this problem. Second method, you can think about, instead of the graphically, we all know they have the 3 roots. We can found all the roots. What is the fx? X cube 3x minus 2023. Now you can see about that. What is the change in sign? I can simply use the discard rule of sign. Fine. So all of you know that there is a one change in the sign. It means it has a one positive root. What is the f of minus x? Minus x cube minus 3x minus here. There is no change in sign. So what is the meaning of that? If there is no change in sign, it means there is no negative real root. There is no negative roots are there. So it has only one positive roots. There is no negative roots. What is the meaning of that? Both the roots are my complex here. So how many real roots are there? Only the one real root is my right answer of this problem. Okay, look at this one. A function is given to you, then which of the following is the restriction of the f is continuous? That's a simple. If I call this is my domain, fine, the function is domain is here, this is my restriction, this is my restriction, and our target is to prove this function is continuous on this restriction. Very simple. If you look about this function, clearly say that f is not continuous at x is equal to 0 only. Fine. So my target is to make this function as a continuous. How you make this function as a continuous? If I eliminate 0 from here, so this subset, it means if I prove 0 does not belongs to this set E, then it is a continuous function. So but you can see the first option, 0 belongs to that. It means this option is cancelled out. 0 does not belongs. This option is the right option. Look at this third option. If I substitute 1, n is my integer number, so n is my greater than equal to 1. So if I substitute in the given function, what is that? Sine pi 1 by n is my here. So n is my integer. So what is that? When n is 1, it is 0. When n is 2, it is 0. When n is 3, it's a 0, 0, 0. Also, it's a union of this. What is the union of this? It is my 0. What is that? It's my constant function. And every constant function is my continuous here. So this is also the right answer. Look at this one. Clearly says that 0 does not belong to this set because n is my natural number. So this is also the right answer. Otherwise, you can also think about the function. If I take about this in here, what is that? This is sine pi divided by 2 raised to power n. So when n is 1, it is my 2 pi. The function is my 0. When n is 2, 4 pi 0, 3 pi 6 0 0 0. It means function is 0 for all x in this domain. Again, it's a constant. Once is a constant, it means this is my continuous is the right answer. So right answers are B, C and D are my correct option of this problem. Okay, look at this one. S is my infinite set. There is no given condition of the infinite set. You may think as Z is my infinite, R is my infinite, or you can think about any of these others. Which of the following is my R here? Is a bijective. As I mentioned you in my previous PY questions, when it's said to be the bijective map, when the cardinality of A is same as cardinality of the B, then it's a bijective. So look at this. Start from the fourth option. F is a mapping from S to R. What is the cardinality of the R? It's a C. Can you think about Z whose cardinality is not C? If I take as S is my Z, what is the cardinality of the S? Alpha naught, which is not same. It is not a bijective. Look at the third option. F is the mapping from S to Q. What is the cardinality of the Q? Alpha naught. Can you think about the S whose cardinality is not alpha naught? If I consider R, then what is that? It's a C. It's not same. This option is also cancelled out. Look at the second option. F is the mapping from S to the power set. What is the cardinality of the power set? It is 2 raised to power S. Now if I consider S is my Z, for example, what is the cardinality of this? 2 raised to power alpha naught. It is C. But what is the cardinality of the S? Which are not same. This option is cancelled out. You may also think about S is equal to R. If S is equal to R, then what is the cardinality of the R is C. What is the cardinality of this here? It is 2 raised to power C, which is greater than of the C, which is not equal. Again, this option is cancelled out. Look at the first option. F is a mapping from S to this. So what is the cardinality of the S? If I consider this is my Z, so this is my alpha naught, or what is the cardinality of the S cross this? Alpha naught cross alpha naught, it is again a alpha. Similarly, you can see about the CR, it is also the same. So it is the right answer is my A is my correct option. Okay, which of the following is my uniform continuous on this closed interval 0, 1? That's a very simple. As I already give you a simple shortcut tricks for you. Whenever the limit of this 0 positive and limit of this 1 minus f, if both exist, only existence is there, whether they are equal or not, that is no problem. Whenever this here, this implies the function is my uniform continuous. Look at that. We all know cos 1 by x or cos pi by x limit not exist at x approaches 0 positive. So it means this is my not uniform continuous. This is my not uniform continuous. Similarly, for the sign is not continuous. Right answer is my B is the right answer. You can check that. When x approaches 0 positive, it will be my e raised to power minus infinity. It is 1 over infinity, that is my 0. It's my finite, it exists. And when x approaches 1, it is e raised to power minus 1, which is again a finite. It means this is my correct option of this problem. Okay, look about this one. F is my here. F is a continuous differentiable function. F is my bounded. This is given to you, and such that here. Then which of the following satisfied? That's a very simple. Again, think about any of the bounded function. Simple. If I say constant function is my bounded, so if I substitute here, x dash is my 1. What is the meaning of that? If I found the solution, x is t plus c and x0 is 0, it means x is equal to t is my solution. So the no solution exists, cancel out. Moreover, the one solution is already given to you here, so this option is cancelled. In the neighborhood of 0, 0, f will not be elliptic. So you can see here, if I take the partial derivative is a 0, it's a bounded. You can see if I take the partial derivative of this, which is 0, it's a bounded. So it means f satisfies the ellipsis property, but he said will not. This option is cancelled. One counter example to disprove that. Solution will be unique or not. So one solution is given to be here. Look at the another solution. If I consider another function like of say cos of t, it is a bounded function. Cos of t is a bounded. So what is that? If I consider x dash is my cos of t, if I integrate them, it is my sine of t plus c. x0 is my 0, it means c is equal to 0. So x is equal to sine of t. Now you can see both the limits, both the solutions are different. Solution will be unique, it is a cancel. When it will be unique, we all remember when the f and the partial derivative of this both are my continuous, but they are talking only about the bounded. Every bounded function is not a continuous function. Okay, so again they are not talking about here or this, that's why they are. Moreover, if you simply take any continuous function, say sine of t, then x dash will be my sine of t. What is the integration is? Minus cos of t plus c. So at x equal to 0, c0, c will be my 1. So x will be my 1 minus cos of t. Again you can see the solutions are my not unique. So the right answer is only my correct option. This is the remaining one is my correct option is the problem. How you can satisfy that? You can see this is given to you. If I take this value is my here and it is given to you as a bounded function. What is the meaning of that? This condition is my bounded, and if you relate them, this is my uniform continuous, right? Uniform convergent or uniform continuous. Every bound is the supremum of this is my here, then it's a uniform convergent. So you can see about here, this is the only right answer of this problem. Now look at this question. So this is the question. As I told you, several students send me in my WhatsApp group that this, according to me, these are the correct options, but student said this is my correct option. What is the tips? As I mentioned you earlier, whenever you have the differential equation of this nature such that y of b is my 0, and if k is my positive, alpha is my 0, 1, and b is in my real number, then you will get as infinite many solutions. Second case, if k is less than 0, alpha belongs to the 0, 1, and b is my real number, then you will get as a unique solution. So look at that. The first one is half. So half, that is alpha lies between 0, 1. This is 0 which belongs to the real. Constant k is my 1 which is greater than 0. So it means p is my unique, infinite. That's the student agree. Look at this one. This is a negative. K less than 0. So according to me, this is the unique solution because this is the tips or shortcut tricks I had given. But what the solution sent to me in my WhatsApp group, they sent me the solution like of this. This is given to you. So they can integrate them. So this is the here. Now you can integrate them. You will get as of this solution. Fine. Now when y0 is 0, it will give you c as a 0. So it means y of half is my minus t by 2. So this implies y is my t square by 4. Now student said if this is the one solution is given to you, it does not give a unique solution. Now look at that. Firstly, we will check whether this is a solution or not. We will satisfy it here. What is a y dash? 2t by 4, which is minus is a t square by 4. Fine. Now you can see t by 2. What is that? It's a plus minus, root of plus minus of this. So clearly say that it is not satisfied. When it is a negative, it's satisfied, but when it is a positive, it is not satisfied. So it means this solution does not satisfy this initial, although it satisfies the initial condition, but it is not satisfied this condition. It means this solution is not possible. Hence, there is only a unique solution is given to you as per my this observation. So according to me, these are the right answers. That's the A and D are the correct options. But student said this is, according to me, this is the argument because it's a plus minus of this. It's a plus minus of this. So this is the, because corresponding to the positive sign, it's a negative. It can never be satisfied. So this option is my not true. So first and fourth are my correct options. So I hope you can simply learn the various tricks and the solution of the real analysis. In the next lecture, we will solve about this various of the OD, PD, numerical analysis, and the many more are there. Till then, you can simply like, subscribe, and share my videos. Best of luck, students. Happy learning.